Hello everyone, and welcome to Numerical series of electrical machine. And today we have already at most five numerical. And the first numerical problem is the armature of 6 pole DC generator has 605 wave winded conductor. Calculate the generated EMF when the flux per pole is 0.055 Weber and the speed of generator is 300 rpm. Also calculate the speed at which the armature must be uh, drawn to generate an EMF of 550 volt if the flux is reduced to 0.05 Weber. First of all, given pole equal to 6, Z conductor 650, value of A is 2, and phi equal to 0.055 Weber, and N equal to 300 rpm. Value of A is 2 because in the question given this is wave winding. So 2, if in the question given lap winding, then we can take A equal to P, that is number of pole equal to, and then the value of A. And to find the value of N2, we know EV2 equal to 550 volt and phi 2 equal to 0.05. This is already mentioned in the question. And we know EB, that is back EMF, equal to phi, this is the formula, phi Z NP upon 60 into A. So put the value of phi Z NP and A, we can get the EB1. And similarly EB2 is already given, phi 2 already given, and EB2 equal to phi 2 Z N2 upon P. Then from this we can get the value of N2. N2 equal to EB2 into 60 A upon phi 2 into Z into P. So we can get the value of N2, and the value of N2 is 339 rpm. And the second numerical problem is when driven at a speed of 100 rpm with the flux per pole of 0.02 Weber, our DC generator has an EMF of 200 volt. If the speed is increased by 111 rpm, that is 111 rpm, at the same time flux is reduced to 0.019 Weber, then what will be the value of induced EMF? Value of N1 equal to 100 rpm, phi 1 equal to 0.02 Weber, EZ1, that is generated EMF is 200 volt, and N2 is 11 rpm, and phi 2 equal to 0.019 Weber. We know E directly proportional to N into phi, that is E Z1 equal to N1 phi 1 and EZ2 equal to N2 phi 2. So EZ1 upon EZ2 equal to N1 phi 1 upon N2 phi 2. Then we can get the value of EZ2. EZ2 equal to EZ1 into N2 into phi 2 upon N1 into phi 1. So put all these value, you can get the EZ2. EZ2 is 210.9 volt. And the next numerical problem is a DC generator has an armature EMF of 100 volt when the useful flux per pole is 200 milliweber and the speed is 800 rpm. Calculate the generated EMF. We have to calculate the generated EMF, and the case first is flux per pole is same but the speed is 1000 rpm. Flux per pole is 24 milliweber and the speed is 900 rpm. Solution: first of all, generated EMF with 100 volt, phi equal to 20 milliweber and N equal to 800 rpm. And case first is phi equal to 20 into 10 power minus 3, N1 1000, and EMF equal to what? And second case phi 2 equal to 24 into 10 power minus 3, N2 equal to 900, EMF equal to what? For we know EZ directly proportional to N phi, and for case first, EZ upon EZ1 equal to N phi upon N1 phi 1. So EZ equal to EZ1 equal to EZ N1 phi 1 upon N phi. So 100 into 1000 into 20 into 10 power minus 3 upon 800 into 20 into 10 power 3. So we can get value 125 volt, case first. For case second, EZ upon EZ2 equal to N upon N phi upon N2 phi 2. Then you can get the value of EZ2. Put all the value, that is value of EZ, N2 phi 2, N phi, then you can get 135 voltage. Similarly, numerical 4. A 12 volt DC motor having 600 lap winding conductor is having uh, flux per pole of 0.55 Weber, which causes it to run at a speed of 1200 rpm. If the armature draw a current of 10 ampere, what will be the armature torque of the motor. Also find the difference in the back EMF induced in the circuit if the speed reduced to 40 rpm with the flux of 0.21 Weber. In the question already given, 12 number of pole 12, value of Z equal to 600 and A equal to 12, because this is lap winding. So A equal to P, that is 12, and N1 equal to 120 rpm, phi 1 equal to 0.55 Weber, I a 10 ampere, and we have to find the torque. We have to find what will be the torque of the armature torque. So tau A equal to what? N2 equal to 40 rpm, already given, and phi 2 equal to 0.01. We know Eg1 equal to, that is back EMF equal to phi ZNP upon P. So put all the value, that is value of phi 1, ZN1, P, A. We can get Eg1. This is 660 volt. And next one is armature torque. The formula for armature torque equal to tau equal to phi Z P Ia upon 2 pi A, and put the value of phi, value of Z, value of P, and value of Ia, value of A. Then we can get torque equal to, armature torque equal to 5 to 5.21 Newton meter. And again E2, EB2 equal to phi to Z2 N2 P upon 60. Then I'll put all these value, you can get the value of EB2. And in the question asks, also find a difference in the back EMF. So this is the difference in back EMF, that is EB1 minus EB2, that is 680 minus 84, sorry, 680, not 600, 660, 660 minus 84, then you can get 576 volt. And the last problem is, a 4-pole DC motor has lap connected armature winding with flux of 0.6 Weber. The number of armature conductor is 250. When connected to 230 DC supply, it draw armature current of 40 ampere. Calculate the back EMF and the speed with which the motor is running, assuming armature resistance of 0.6 ohm. Value of P already given in the question. Value of A equal to P because it is lap winding, and phi equal to 0.6, Z equal to 250. That is Vt. This is a Vt, and this is a circuit diagram of above numerical problem. Vt equal to 230 volt. When connected 230, this is the supply, so 230 volt. I equal to 40 ampere. We have to find Eb N, where Ra equal to 0.6. From the circuit, we know Vt equal to Eb plus IaRa. This voltage equal to sum of this voltage, as Eb and IaRa. Then Eb equal to Vt minus IaRa. Put the value of Vt, IaRa, we can get the value of Eb, 206 volt. And we also know Eb equal to phi ZNP upon 60A. So N equal to 60A Eb upon phi Zp. Put the value of A, Eb, phi Zp, we can get speed 83 rpm. Speed is 83 rpm and back EMF is 206 volt. In the question we have to find back EMF and the speed.